Assalamualaikum warahmatullahi wabarakatuh. A very good morning to all of you students. Are you feel healthy today? Are you feel energetic to learn about today's chapter? So today in class we learn chapter 6, linear equations. Alright, in my class there are rules. So students, please do focus and listen where during class. Have a physical stretching to stay active during classes. Open your mind if you have any question. Open your camera during class unless you encounter any problem. Open your camera during class unless you encounter any problem. And please don't sleep during my class or snap without muting first or turn your camera off for a long time. Alright, that's all. So for today's topic is 6.1 linear equation in one variable, 6.2 linear equation in two variables, and 6.3 simultaneous linear equation in two variables. So let's not waste any time. So we'll go with introduction of video about what is linear equations.
This lesson is on what a linear equation is. And the answer to that question is essentially a linear equation is any pattern of numbers that is either increasing or decreasing by the same amount every step of the way. This means that the only two things we need to define a linear equation are where the pattern begins and how much the pattern moves by. What that leaves us with is what's called the slope-intercept form of a linear equation, where the m value is our slope and the b value is what is called the y-intercept. Some examples of a slope-intercept form equation we could have something like y equals 2x plus 1. We could have y equals negative 3x. We could have y equals 2/3 x minus 6. In each of these equations, the number in front of the x represents the slope, or how much it's moving by, and the number on the end represents the b value, where it begins, or the y-intercept. If there is no number after the x, that implies that the y-intercept is 0. So what's the point? Why do I care about a linear equation? Well, linear equations are the most common patterns of numbers we see, and they really are great for describing all sorts of situations you see all around you. One example is having to do with the car that I bought. As soon as I turned 16, parents helped me buy a used car. When I bought my car, it had 27,000 miles on it. And I've owned it for a while now. And every year I drive it about 12,000 more miles. And so what we end up with is a linear equation to represent the situation that looks like y equals 12,000 x plus 27,000, because I drive it 12,000 more miles every year, so that's how much the pattern moves by. And the pattern began at 27,000 miles when I first bought the car. So after year 1, it had 39,000. Then after year 2, it had 51,000. Then after year 3, it had 63,000, and so on and so on. Drawing a graph of this linear equation can help us make a lot of predictions about what this pattern is going to do in the future. And it can also give us a better sense of the pattern that might not be quite so easy to see just from looking at the numbers. When I want to graph a linear equation, I use the y-intercept, the b value, as my beginning value on my graph. And before I had owned the car for a single day, it already had 27,000 miles on it because I got it used. Then, after 1 year, I was driving it along, and after year 1, I was up to 39,000 miles. And I kept driving it. After year 2, I was up to 51,000 miles. So every time I go over 1 year, I go up 12,000 miles.
All right, that is a linear equation. What can you grab about the concept of linear equation? So linear equations, the variable always power of 1 or the degree is 1. So for example, y equal to x power of 1. So y is power of 1 and x is also power of 1. So this is the example of linear equations. So y equal to 2x plus 1. And what is not linear equation is y equal to 2, y equal to x squared plus 1. So x squared is x power of 2. So power of 2 is not a linear equation. Now let's continue with 6.1 linear equation in one variable. So in this 6.1, student will be able to simplify the linear equation in one variable and graph it. All right, a linear equation one variable that is general form like this one, ax plus b equal to c, or ay plus b equal to c, which a, b, and c is a constant number, which is can be 3, 2, 1, anything number, any number. And then we simplify the linear equations like this. We get x equal to p and y equal to 3. For example, p is 3, q is 3 also can be. So that's do example 1. So 3x plus 2 in bracket equal to 5x. So 3x plus 6 equal to 5x, right? So equal to 5x minus 3x, right? Then we get 6 over here, right? And 6 equal to 2x, right? And we need to change to general form like this one. This example, right? So 2x equal to 6, right? So 2 is A and B is 0 and C is 6, right? So, and then we get 2x is x equal to, right? X equal to 3. So this 3 is over here. So this is x equal to 3 like this. That is the example. So next example is y over 6 plus 3 equal to 5. So we need to simplify this. So y over 6 plus 3 times 6 equal to 5. Also must be times by 6. So we get y plus 18 equal to 30. So we get what? 12, right? And this is the general form of this one. So y equal to 12. What is y equal to 12? So y equal to 12 is here. For example, y equal to 12. And for example, that you get x equal to 3, right? So it can be around here. X equal to 3 like this. So that is how we graph the equation. So by using GeoGebra, for example, 1 and 2, we can compare it even in the general form, and after we simplify, the graph we get is still the same. Now student, we will start the first activity using GeoGebra. So we use this example, we will compare the standard form, and after we simplify, if the equation is the equation of this one and this one is the same, we will compare it. All right. So for the first 2x plus 0 equal to 6, which is x, after we simplify, we get x equal to 3, right? So yes, let's find it out. So a is 2. A is 2. Look at it. A is 2. And B is 0. It's easy for me to do this. And C is 6. Right? 6. Then we will get the equation. This is 2x equal to 6. Same as this. So if we change it to this one, we get x equal to 3. The same, right? Okay, for the second equation, we use this y plus 80 equal to 30. So after we simplify, we get y equal to 12. And this one, okay, a is 1. A is 1. You just think, see for me. 1. B is 18. B is 8. B is 18. And C is 30. And the same this one, y plus 80 equal to 30. And y equal to 5, the same, right? So hence it proves that after we simplify and in the standard form, we get the same line. For this one, the vertical horizontal line, and for this one is horizontal line, and for this one is vertical line. So we get x equal to 3 and y equal to 12. And from this, we can get a coordinate. So which is x equal to 3 and y equal to 12. So we can get a coordinate over here. And we will have more equations for equation 3 and equation 4. So we have the intersection point like this, or coordinate. This coordinate we can like this. We have coordinate A and B. And using this 2 point, we can lead it and we can create a linear equation in 2 variables like this one. So we have this is y equal to 1.78 x plus 6.67. And this one, so we get y equal to negative 1.78x negative y equal to negative 1.78x plus 1.23. So we see the almost similarity. So this is using the standard form, which is y equal to mx plus c. So m is almost the same, right? But this one is positive and this is negative. So m is for you to know is m is a gradient of slope. So it's a value of m. And this is 6.67 is value of c or the intercept of y. The same as this one. So this is the introduction for you to understand the equation in 2 variables, the linear equation in 2 variables. So you can look, you can play, I can play with this and you can see it. See it. Nice, right? Very beautiful. This is the introduction for you to understand about the equation, linear equation in 2 variables. Student, in 6.2 linear equation in 2 variables, you'll be able to differentiate between the general form and the standard form of linear equation. And you will also able to craft the 2 variable linear equation. So there is general form and standard form. So general form is ax plus by equal to c, which is s and y is variable and a, b, c is a constant number. For the standard form, y equal to mx plus c, where m is a gradient and c is a intercept y. So the gradient formula is y2 minus y1 over x2 minus x1. Before I forget, gradient can be also called as slope. And the parallel line m1 equal to m2. For example, parallel like this. This is parallel line, so m1 must equal to m2. And for the perpendicular line, if you see something like this is 90 degree like this. So m1 times m2 must equal to -1. Right, that is for introduction. So for example 1, state 3 possible pair of solution for 2x plus y equal to 1. So for example, x equal to 0, 1, and 2. So like this. So we just substitute the value 2, 0 plus y equal to 1. So y is equal to 1. And this is 2, 1 plus y equal to 1. So y is -1. So next is 2, 2 plus y equal to 1. So y is -3. Right. So it can written by so this is can write. So in here we can write in order of pair like this x, y. So 0, 1, 1, negative. That's negative. All right. now Now, for example 1, state 3 possible pair of solution for 2x plus y equal to 1. So, for example, x equal to 0, 1, and 2. So, 2, 0 plus y equal to 1. So, y is 1. 2, 1 plus y equal to 1. So, y is -1. And 2 times 2 plus y equal to 1. So, y is -3. So, it also can write in the order of pair. So x, y like this. So 0 and this one 1. This is 1, -1, and 2, -3 like that. So we can use this point to plot this equation. So 0, 1, yeah, 1, -1, and 2, -3. So then we write with it, but we graphic straight line. Must be a straight line. So that this it is 2x plus y equal to 1. But we also can teach it to a standard form. Standard form. So if standard form, y equal to -2x plus 1. So 1 is over here, 1 here. So another value we can take this for example 2, -3, and we just plot it like before because it's straight line. It will be the same. Must straight line, must straight line. So to find a gradient, we know that gradient is -√2, right? So we use this one, 0, 1, and 2, -3, right? So for example, we pick this one first, -3 minus 1 and 2 minus 0. So we get the value is -4 and 2. So that's why we get the gradient is 2. The gradient is -2. Correct. Sorry. Okay. For GeoGebra activity, we need to graph 2x plus y equal to 1. So the general form ax plus by equal to c. So 2x plus y equal to 1. And the standard form y equal to mx plus c, and we change it like this. And then we will compare it, the general form and the standard form. Either the graph will be the same. We use GeoGebra to for you to observe. It's either the graph will be the same for general form and the standard form. Student, now we will continue with the second activity using GeoGebra. So we will use this example. So we will graph 2x plus y equal to 1 using the general form and the standard form, and we'll compare it using GeoGebra. So if is this the graph will be the same if you use general form or standard form, or it will be different, or it will be different. Let's observe using GeoGebra. Okay. For the first equation, so we get, so first equation is ax plus by equal to c. So this is the general form first. So 2x plus y equal to 1. So over here, 2, 2, and we get this over here is equal to 1, b equal to 1, and c equal to 1. C equal to 1. Okay. So that is for the general form. So that is the graph of the general form. And for the standard form, this is M equal to 2 and C equal to M equal to -2 and C equal to 1. So M equal to -2, -2, and C equal to 1. That is the for graph for the standard form. And it's the same, right? The same as the general form and the standard form. So using the both, we will get the same graph. So how about if we change value of M? M is a gradient. So if you increase the value of C, like that, C, and then this decrease, if it's decrease, it's move. If you negative, you go to this side. If you negative, you go to the right side. Okay. And for C, if you see this, C can, if you see C is, if C is increased, then the value in the intercept also increase. For example, for 5, you get 5. And if, for example, if negative 2.5, you get like that. If 3.5, you go like that. See, so and then we change it back to the original, like the 2 and 1. C is 1. C is 1. All right. And then we have the parallel with the equation 1. How is parallel? Parallel is mean that you have the same like this. So this parallel. This for this equation, the green line and the orange is parallel. No, right? Now to get the parallel line, you must have m1 equal to m2. So m1 now is -2 for the equation 1, and m2 is -0.2. So that's why it's not parallel. So to get the value of that one, we must change m2 to -2 also. m2 to -2 also. -2. Then we get parallel point. And if you change the C value, the equation of the green one will be always parallel if you change the C value. How C is increased or decreased, the green equation with the equation 1 will be parallel. The green equation will be parallel with the orange equation. See how many if we change the value of C. But if you change the value of M, it will not be parallel. All right. For the perpendicular with the equation 1, so perpendicular you mean that you need to get the degree is 90 degree. Now it's not 90 degree. And we need to get M1 times M2 equal to -1. Then we will get angle is 90 degree. So we will find it for the proper one. And we close the green one first. And then we open the proper one. Okay. So the M is now is -2, right? M is -2. So -2, if you want to get over here is -1. This is not now it's not -1. So we need to get -1 of M1 times M2 equal to -1 using the formula we learned before. So M2 must equal to 0.5. So 0.5 is hard for me to get the value for that. 0.5. And we will get the 90 degree. So this we call this perpendicular with the equation 1, which is the purple equation and the orange equation will be perpendicular, and the purple equation also will be perpendicular with the green one also. And if we change the C value for this one, it will always perpendicular. It will not change. It will not change unless you change the m value, and it will not be perpendicular. The same as the parallel one. And from this also, if you see the equation line, we have the intersection of between the linear equation of two into variables. So we get, and this is the what you will learn how to find the intersection between the equation in linear equation into variable. For example, we take this one. When we get the equation, the intersection between the equation between the two linear equation into variable. Same as this one, we get the equation also. And that is the intersection for the intersection point in 6.3 like that. 6.3 simultaneous linear equations with two variables. In this topic, students will be able to find the intersection point through substitution and elimination method, and students also will be able to graph and show the intersection point. By graphing method, we can find the intersection point also. There are two methods in graphing. So first method is by using the table. So 0, 1, 2, we get the value 3x. So 3, 0 plus 3y equal to 9. So we get y equal to 3. And 3, 1 plus 3y equal to 9. We get 3y, 6. And y equal to 2. And 3, 2 plus 3, y equal to 9, and we get 3y equal to 3, and y equal to 1. Then we get 0, 3, 1, 2, and 2, 1. Right. So we put this and we point it. So 0, 3 here, 1, 2, 1, 2 here, and 2, 1 here. Then we do a straight line. 3 follow the point, should be like this, right? And then there are second method we use is which if we find the intercept x and intercept y, c value. So when y equal to 0, we get the when y equal to, by second method we find the intercept x and intercept y, c value. And when y equal to 0, we get the intercept x, which is like this, 3x plus 3, 0 equal to 9. So x equal to 3, right? So when x equal to 0, like this one, we get y equal to 3. So that is the intersection at x and y. So from here, we can also get the same like this one. Yeah, but we just use the intersection point only. So this is 0, 3. This is 3, 0. Then we graph it. And from the graphing method, we also can find the intersection point. For example, we use y equal to x. So y equal to x is this one, which is like this. And then we get the intersection point this, like this. And we get value this, like that. Okay. By substitution method, we solve it using the substitution, which is x minus 3y to 7 and 5x plus y to y to 1. So this is 2, this is 1. Right. So x equal to 7 plus 3y, the third equation, and third equation substitute into second equation, 5, 7 plus 3y plus 2y to 1. So 535 plus 50y plus 2y equal to 1. So we get 70y, and this is negative 34, right? So y equal to negative 2. And from here, we get the fourth equation. And the fourth equation, we substitute into third equation. And this, we get x equal to 7 plus 3 minus 2. So we get x 7 minus 6. So x equal to 1. So the intersection point is 1 and negative 2. By using elimination method, we also can get the same intersection point on the same equation, right? So x minus 3y equal to 7, right? And 5x plus 2y equal to 1. So from here, we need to eliminate it. For example, we eliminate value y first. So we times all this by 5. So we get 5x plus negative 50y and 35. Then 5x plus 2y equal to 1. This is times by 1. And then we minus it. And we get value minus 70y. And this is 34, right? So y equal to negative 2, right? So from here, you can use substitution method. For example, like this, x minus 3, negative 2 to 7. Then x plus 6 equal to 7, x equal to 1, right? So we get the same point as 1 and negative 2. By GeoGebra activity, we can compare it, the intersection point using elimination. But in GeoGebra activity, by using GeoGebra, we can find the intersection point x minus 3y equal to 7 and 5x plus 2y equal to 1. And by the standard form, we can compare it. Either the intersection point we get it are correct or not. So we can use GeoGebra to prove that elimination and substitution method or graphing method are correct by using GeoGebra. So then in the third activity using GeoGebra, we will find the intersection point x minus 3y equal to 7 and 5x plus 2y equal to 1. And we will change from the general form to standard form, which is y equal to mx plus c, which is the first equation is y equal to 1 over 3x minus 7 over 3, and y, and for the second equation, y equal to negative 5 over 2x plus 1 over 2. And we compare it using GeoGebra. And we prove to you that the intersection point you get through the elimination and substitution method, you will get the same coordinate. You will get the same x and y value. Okay, now we will try to prove to you that using GeoGebra, the same value as you get using the substitution and the elimination method. So m is 1 over 3. For the blue one, we change m1 to 1 over 3. 1 over 3. And c is, we change to negative 7 over 3. Negative 7 over 3. Negative 7 over 3. And we get this one. This the graph of the question is over here. And then the second question, negative 5 over 2 plus 1 over 2. So negative 5 over 2 is m value. So negative 5 over 2, which is 2.5. Negative 2.5. Negative 2.5. 2.5. And 1.1/2 is 0.5. So C value is 0.5 or 1/2. And that's the equation. And that is the intersection point we get. So we show to you that, and we get the value of the intersection point is 1 and -2. So the x value is 1 and the y value is -2. And hence we prove that using GeoGebra, we can prove to you that the intersection point is the same as we calculate using the elimination and substitution method. But using GeoGebra, we can see more clearly, and I can prove to you that the intersection point you find using the other method is correct using GeoGebra, as you can see in the GeoGebra. So I will give you this GeoGebra file for you to play and to understand about the intersection point. Or maybe you can, if you want to do the other question about the intersection point, you can use this thing to find the intersection point to make confirm the answer of your intersection point of the question. Okay, thank you. So this is today class activity for class. So student, all you need is you have to show me intersection point in graph by graphing the simultaneous linear equations. So y equal to 3x plus 1 and x plus 2y equal to 64. Question A, and question B, x plus y equal to 5 and 2x minus 5 equal to 22. And you can use this technique to graph the linear equation like this, that's mentioned like this, like I teach you before. So you can take your time. I will give you around 10 minutes to complete. All right, this is the answer for your friend. So now let's continue with our class activity. So this is the answer for A, which is given by your friend. So, all right, it's correct. But I would like you to graph it in the paper graph. Okay, next time. All right, thank you. And for others one, also the same. The answer is correct. But if you do like this, you cannot find the intersection point, but you just can show it, right? But you cannot find it exactly where is the intersection point, where is the point. The point is what? X is what's the value, y, what is the value of y. So what is the point? Intersection point. We need this exactly. By using a graph paper, we can find exactly the intersection point as we find using the elimination or substitution method. Thank you. Nice, good job. So now let's recap the linear equation. So what we learned in 6.1 is about one variable. So that's in the form ax plus b equal to c, or ay plus b equal to c, where a, b, and c is a constant. And then we simplified it. For example, x can be 2 or y can be 2. Can be any number. After we simplified it. And then we learn about two variables where they are general form ax plus by equal to c, and the standard form y equal to mx plus c, where m is gradient and c is intercept y. And also we learn about simultaneous equation. So we find the intersection point using the elimination method, substitution method, and graphing method. And usually it's happened during two variables, for example, x and y. So for conclusion, I will need your feedback about 2D class. If there are any weakness or strengths of 2D class or improvement that can made by me, please give a feedback. And if you also have problem understanding our 2D chapter, please also give feedback to me also. I will give you the Google form later. And if you have any question, you can ask after the class. You can ask after the class in the group. And homework is a must for mathematics learning. So this is your homework. So All you need to do is you solve the simultaneous linear equation by finding the intersection point using the three methods with substitution, elimination, and graphing, and show your work and send it to the Google Classroom. So this is the equation. Please, if you screenshot it, or I will show you the slide later. Okay, and thank you for attending my class today. Assalamualaikum warahmatullahi wabarakatuh.